All right. So what is the real difference? So I tried to kind of paint a picture here of what is the difference as I see it between the Hive world and kind of like the Iceberg world. So if you look at this, on the left side, we have sort of high level representation of the Hive world, where you have the Hive catalog on top, and then that has a pointer to a set of folders, and these folders are typically Hive partitioned. Commonly, we see a year, month, day type of partitioning, and the year is a folder. Inside that folder, there's multiple month folders. Inside of that folder, there's a bunch of Parquet files, right? So the schema, partitions, column metrics, all the table properties all reside in a catalog. And then the partitions are statically defined via this folder structure. And when you create a table, you say, hey, these are my partitions, but the actual partition layout is hard-coded in the folders in S3. If you wanted to add a partition, you have to add a folder. If you want to get rid of a partition, you really can't, because now you have all this data. You have to reshuffle it and move it around. So you have to do a lot of rewriting. On the Iceberg side, there's a lot more functionality here, but if you can see, it's sort of spread out across a number of different components. The catalog itself, though it can be a Hive Metastore catalog, there is an Iceberg REST catalog, which basically says, hey, there's a lightweight version of a lightweight way of creating a catalog that doesn't have a ton of dependencies on Hadoop and Hive and Thrift and all these kind of archaic technologies that have been used in the Hive HMS world. We can do it better, easier. We know how to build web services nowadays, right? So there's a Stern kind of spec around that Iceberg REST catalog that says, how do I list tables? How do I, update tables, et cetera, et cetera. But the gist is that catalog is actually a very thin layer compared to the Hive one. It holds a couple important things. The first one is the active snapshot pointer. And that's a pointer to the metadata file that tells it what is the active snapshot or the current snapshot for that table. It's also the table pointer. It basically says, like, this is where I find my data, right? Everything you need to know is in this location. And then there's some concurrency controls, right? Concurrency control, I think that's where sort of the innovation around the Iceberg catalog is going to come in, is how do you manage multiple writers and readers of the same table, multiple systems updating data together. If you have any questions, please drop them in the chat. I will try to answer them there. I'm trying not to stop everything else. Okay, sorry. I'll get to the question at the end. On the metadata side, so there's the Iceberg table is broken up into metadata file, manifest lists files, and manifest files themselves. The metadata file is really where the table schema is stored, table properties. It also gives some kind of snapshot isolation. So we no longer need to go to a catalog to figure out the schema. The schema resides with the table itself, right? As well as all the properties that go with it. The manifest list, you can think of it as a file that says, if you want to access the data files, here is a list of other manifests that know where those files are. But the good thing about this manifest is that it actually gives you some hints. It says, if you really want to get to this file that holds, row where the customer ID is 1000, you should really go look at this manifest file over there. But if you want row ID 2000, you should go look at this other manifest, right? So these metrics and hints, in a way, help you prune which direction or which files you're going to end up querying. So it's a really powerful way for the query planner in a query engine to quickly figure out which files it needs to read and be able to do that. Traditionally, that's been done through looking up the Hive catalog, bringing in all the metadata, and then parsing it on the local engine. And that piece took a long time, especially for large tables. Same thing with the manifest files. It's a file that lists all the data files where they're located. It's used for deletes and updates and tracking, but it also minimizes your S3 list. Right now, I don't have to go to a folder and say, okay, list all the files until I figure out which one I want. I just go to the manifest file, I open it, and then here I got all the list of files, and I can look based on the metrics and some of the statistics in there, and I can figure out which files I really need to read. And then we have varying folders. You notice here that the folder structure doesn't actually matter for Iceberg. You can have it in a static Hive partition if you are migrating from an old Hive table. It can just be like one folder with a bunch of data. It can be different folders in different places. That's a really powerful feature of Iceberg, right? So your data can really be scattered. The manifest files are the ones that define the structure of that table and how partitions are laid out.